Go.
Today we're going over naming of covalent ionic bonds. So a few things, characteristics about each one first. Covalent bonds are between two nonmetals, and they share bonds, meaning they share their valence electrons. So their bonds are much weaker than ionics. Ionic bonds, however, there's an ion present, and that means that it's a bond between a metal and a nonmetal. So there's a separation of charge, meaning if you want to write an ionic compound, you have to make sure their charges match as well and equal out to zero. So the thing with covalent bonds is when you're naming them, the first element, you give it a prefix if there's more than one. If there is not more than one, you just write the name of the element. And the second element, no matter how many you have, you will always give it a prefix. So even if it's one, like here, that you would still give it a prefix of mon, which means one. So if you want to write these out, this would be nitrogen dioxide. So you would be that just because you only have one nitrogen and two oxygen, and di stands for two. And this one would be, since you have two in the first element, you would have di phosphorus. I spelled that wrong. Pentaoxide. Because you have 5 oxygen molecules, or 5 oxygens. And this one, since you have just CO, it would be carbon. And since you have to have a prefix for the second one, it would be monoxide. And that would be how you would write out these three. And you can do the exact same thing, but backwards, where you are given the name of it and you have to write the covalent bond. So carbon tetrachloride would be equal carbon, which is just C, and then you would have 4 Cl's. So it would be Cl4. And sulfur hexoxide would have one sulfur here, and 6 oxygen molecules. So it'd look like that, SO6. Now, moving on to ionic compounds, how you name these is slightly different, and what you do is you want to write the cation first, which is the ion with the positive charge. And that's usually a transition metal, or not always, but it can be a transition metal. And if it is a transition metal, you want to put empty parentheses in front of it. And so this one, magnesium, is not a transition metal. So it would become this one right here. Oh, and the anion, if it is an element, you would add an IDE at the end. But if it's a polyatomic ion, then you just keep the regular name. So this one would become magnesium. Chloride. Whoops. Here, because you have a transition metal as the cation, you have to do iron, and it's based on how many of these you have, because their charges matter. So since chlorine is a charge of -1, and you have 3 -1s, that means iron has to be 3, which means it has a charge of +3, and then chloride. Now, the same can be done backwards, where you get the cation and the anion, and you have to write the ionic compound. So for this, iron 3 would be Fe, and since it has a charge of 3, and carbonate, which is CO3, has a charge of -2, what you have to do is you have to balance these before you can write it in the right way. So the correct balance is you want to get them so that they equal to 0. So you would multiply this by 2 and this one by 3. So you get 6 on each side. So it's equal to 6 and plus or minus 6. So now what you would write is Fe2, and you would write, since this is a polyatomic, you would write it in parentheses, CO3, and then put a subscript of 3 to emphasize that there are 3 of these carbonates. Thank you for watching.